for today about factoring. We've talked a lot so far this unit about what happens to conjugates. When you FOIL two things that are conjugates, meaning not quite opposites of each other, but conjugates, what happens to that middle term? Well, we've seen this. You multiply the x times the x. When you multiply the x times the 3, and then the negative 3 times the x, those two terms will always be opposites of each other, and they will always cancel each other out. Always, always, always. When you multiply two conjugates, those two middle terms will cancel out. And what you'll be left with is just x squared minus 9. We've given that a name. X squared minus 9 is called a difference of squares. So we've seen this a bunch. Some of us are taking shortcuts. When we see that we're supposed to multiply a difference of two squares, we kind of skip the middle part because we know what's going to happen, and we go right to that difference of two squares. Well, if we can take that shortcut when we're multiplying, we can take that shortcut when we're going in the other direction also. So if I see x squared minus 64, if I notice, hey, that's a difference of two squares, its factors must be conjugates. Because if the product of two conjugates is a difference of two squares, then the factors of a difference of two squares must be conjugates. So we know that what's going to happen in the middle is just going to be setting up that x squared plus 8x minus 64. We don't need to worry about that. You don't need to think about looking for numbers that multiply to negative 64 or add to that missing 0 that's in there. I mean, it works if you want to, but you can take a little bit of a shortcut and not worry about that. Or x squared minus 49, as long as it's a difference of two squares. Keep in mind, by the way, the difference part is important. If it's not minus, none of this works. But the difference of two squares, x squared minus 49, its factors are x plus 7 times x minus 7. And this is particularly useful for more complicated difference of two squares. As long as we notice that both 25x squared and 144, as long as they're both perfect squares, it must be the result of multiplying two conjugates. Multiplying 5x times 5x would give us the 25x squared. Multiplying the 12 times negative 12 would give us the negative 144. And because these are two conjugates, when you multiply them, the middle terms would definitely cancel out. In this case, it would be a plus 60x and a minus 60x. But we don't care what they are. We care that they cancel out, and that makes the factor